Hello students, today we are going to begin a new class of biomolecules. Those are lipids. Sometimes we also call it fats. Lipids are a group of biochemicals where the defining criterion is its solubility. We just cannot define it using any chemical formula or any chemical definition we cannot give it to lipids. Lipids are better defined by their solubility property. That means what happens, we just take any living organism, grind it to a homogenate, then take that homogenate, mix it with any organic solvent like say chloroform or ether and stand it for some time, allow it to be there for some time. Then all the lipid fraction will come to the organic solvent phase, and when we take those organic solvent we will and evaporate it, we will find the lipid to be present in it. Unlike other chemicals, say for instance monosaccharides, we define monosaccharides as polyhydroxyaldehyde or polyhydroxyketones. So this definition shows its chemical aspect. But lipids, we just simply say these are the biomolecules of, these are the molecules of biological origin which are dissolved in organic solvents and insoluble or sparingly soluble in polar solvent like water. That means they are soluble in organic solvent and insoluble or sparingly soluble in polar solvent. Like water. So this is a physical property. This is a physical property by which we actually define lipids. So this lipid term came from a word, Greek word lipos, which means fat. From that term, this lipid have originated. Now, we will see, as we are seeing here, that they are depending on the physical property. They are depending on the physical property for their classification. We can well imagine that they are chemically a very diversified group of chemicals. Chemically, they are a very diversified group of molecules. Now, we will just see what they can be used for and how we can classify them. First of all, we consider storage lipids. We can divide them into three categories. One is storage lipids, another is structural lipids, as the name suggests, you can see that we are just not using any chemical parameter to define them or even to classify them. We are mostly looking at what they do. And other lipids, again a very diversified group, other lipids. So what this storage lipid does? It stores energy. It stores energy. They are mostly fats and oils, waxes. Fats, oils and waxes. They are fats, oils and waxes. They are very good, those molecules which come under them, they are very good energy storer. We can store energy sufficiently there. You can just imagine when we oxidize these molecules through our metabolic process, will yield a lot of energy. In comparison to proteins and carbohydrates, it will yield around twice, more than twice what they can yield. It is because these are extremely saturated with hydrogen. There is hardly any oxygen, so it can yield, they are in a very highly reduced state. So when we oxidize, it yields lot of energy out of it. Besides these waxes, they also store energy, but other than storing energy, they can also they are found over the feathers and hairs, feathers of birds, hairs of mammals, and they coat it because they are extremely water repellent. They are extremely water repellent, so they are used as a coat over the hair and feather. And also in plants, particularly the xerophytes, we will find the cuticle of them is made up or is coated with waxy substances. So the purpose is to prevent water loss. Purpose is to prevent water loss. Then when we come to the structural lipids, they are mostly, you can say, the lipids found in the membrane. Lipids found in the membrane. They can be phospholipids, or glycolipids, sterols, and so on. Well, so under this storage lipid, we will be studying, it is in our course. Course includes this fatty acid, neutral fat, phospholipids, glycolipids, and steroids. So fatty acid and neutral fat, they will be under this storage lipids. Then phospholipid and glycolipids, they will come under, and also you can say that the steroids, they come under the structural lipids. Then under these other lipids, we find again a diversified, very highly diversified, and they mostly do some action in our body. They help in metabolism, they do some action. They can be enzyme cofactors, like lipoid. If you have gone through the Krebs cycle reactions, there you will find there is an enzyme, that is your pyruvate dehydrogenase complex, and in that pyruvate dehydrogenase complex, a coenzyme is there, its name is lipoid. So another thing we also find them as electron carrier in ETS. They are the coenzyme Q. So this is also there. Then we will find that light absorbing pigments, all are there, come under lipids. Absorbing pigments found in the chloroplast. They are the chlorophyll and carotenoids. Chlorophyll and carotenoids, light absorbing pigments. Then we will have the vitamins. Vitamin A, D, E, and K. they come under this category. And we will also find hormones. The steroid hormones. The steroid hormones, this we are going to, it is included in the course, in the syllabus it is present. Then we will find another important thing, that is the hydrophobic anchors. For membrane protein. And we have also molecular chaperones, which help proteins, they help proteins in folding. And they are also intracellular messengers. One such messenger we will study. And finally, we can say the antigens. This also I will come to it. Antigens which are present on the cell membrane surface that will produce antibody in our body. So, they are part of our immune system. So, you just see what is the diversified functions, biological actions they are doing. They will store energy as fats and oils and waxes. They will give a protective coating over the leaves, hairs, feathers in form of waxes. Then they are the main rather we can say the main molecules making the membrane. All the membrane means plasma membrane, nuclear membrane, membrane of the endoplasmic reticulum, membrane of the mitochondria, all the cell organelles surrounded by this unit membrane. These membranes are made up of a particular group of lipids, what we call them phospholipids and sphingolipids, glycolipids, etc. So, next we come to other than these two very important functions, we find them that enzyme cofactors, electron carriers, light absorbing pigment, vitamins, hormones, hydrophobic anchor, chaperones, then intracellular messenger as well as the antigens. So, from these we will first take up the storage lipids first, and under the storage lipid we will be studying fatty acids and neutral fats, because neutral fat is made up of fatty acid. Neutral fat is made up of fatty acid. So also phospholipid also made up of fatty acid. So fatty acid will be found here in the neutral fat, in the phospholipid as well as in the glycolipid. In all these three categories we will find fatty acid to be present. We will first cover the fatty acid, then we will come to the neutral fat, then we will come to the phospholipids, glycolipids, and when we come to the steroids, we will find that it comes under this hormone category. So, under this other lipid category, the steroid will come. The steroid we will find once in the plasma membrane, and again we will find them working as the hormone. So, let us begin with fatty acid. The name is interesting. The name fatty acid is interesting in the sense that these are the acids which we find in fat, rather we can say. Actually, what are these? These are simple carboxylic acids. These are simple carboxylic acids, but the only thing is that carboxylic acids which we find in fats, Interesting feature of these fatty acids is what? We will find that usually the number of carbon atoms number of carbon atom is more. At least it should be 10. At least it should be 10. And another aspect of these fatty acid is that they are never branched. We never find them to be branched. They are always straight chain. But as you know, in biology, exception is always there. We will find exceptions. So there is one fatty acid that is called lactobacillic acid. So this one is actually branched. Otherwise, all of them are unbranched. They are never branched. Here what happens, I will come to this structure aspect later on. And another thing is that sorry, here it is not branched. Here we will find, here there is a ring. We will find a ring to be present in this lactobacillic acid. And here tuberculic acid. Here it is branched. These two are very interesting. Here these are two very interesting fatty acids. They are the exceptions. Tuberculosteric acid. Tuberculosteric acid, that is branched. Well, now all these fatty acids are amphiphilic. What is the meaning of this amphiphilic? Means we will have one hydrophobic region and there is one hydrophilic region. You can understand this aspect when I draw the structure. Let us draw the structure of one fatty acid. When we draw it, you can understand. As I said, these are the carboxylic acid. So carboxylic acid means at one end there will be the COOH. So let us begin with say CH3, CH2N, then say another CH2 and C double bond OOH. This is what you can say, this is what a fatty acid is. This is one fatty acid. Here what happens, you can mark that this is the hydrocarbon chain. This is the hydrocarbon chain. It is completely hydrophobic. This is completely hydrophobic. Charge is totally neutral. There is no charge at pH 7. And we will find this COOH, this is the carboxylic acid group. This is the carboxylic acid group. So here this hydroxyl group, this one is, it will donate this hydrogen. So this becomes what? C double bond O 1 minus. So this ionization, because of this ionization, make this end hydrophilic. I hope you understand. Hydrophobic means that will repel water. Water will not come in contact with that part of the molecule. Whereas when we say hydrophilic, water molecules will be very closely positioned to them, because here is a charge, negative charge, and water molecules are having charges on them. This is water molecule, this is oxygen, and this is hydrogen, this is hydrogen. We will find small positive charge here. Here is a small positive charge, and there are two small negative charges on the oxygen, on this molecule. So, this molecule, if we say this is the axis of the molecule, we will find this is negative, this has negative side and this is the positive side. So, when there is an ion, if it is a negative ion, all water molecule will be attracted towards it and will arrange like this, hydrogen towards this molecule, towards this particular ion there will be hydrogen. So, it will be surrounded by water molecule because water is attracted towards this charge. So, this is what hydrophilic. But since there is no charge in this part of the molecule, it is hydrophobic. Because in one molecule we have one side completely hydrophobic and another side that is hydrophilic. So, we call this amphiphilic. Amphi means both. Amphi means both. So, both water loving and water hating, or you can say loving the polar substance and loving the apolar substance or non-polar substance. It will actually amphiphilic, philic means loving. So, what it is loving? It is loving polar substance, the polar group and non-polar group. Both it is loving. But when we, then what is this non-polar substance? This part is the non-polar. This is the non-polar. What is, I have written here hydrophobic, that is non-polar. And this is polar. What is I have written? Hydrophilic, polar. We can find the polarity here. So, another characteristic feature of this fatty acid is that they are actually amphiphilic. It means what happens when it is when there is an amphiphilic substance. If we take water, put a spoonful of such amphiphilic substances in it, then shake the water, we will find that these molecules are present on the surface. They will make a film of this substance on the surface of the water, and where the hydrophilic head is immersed in the water and the hydrophobic tail is away from the water, maybe to the air. There is no problem. Even if we force them to be inside water, it will never come in contact with water. There will be a void around it, even if it is inside the water. And at that time, disorderliness or entropy of the water will be extremely reduced. Now, another important aspect of this is that all these fatty acids are found esterified to fats, most of them, mostly esterified. You can say that simply they are joined to esterified in fat. I'll just explain all these things in detail later on at its appropriate place. Now, rarely we find free fatty acids in our body. Another important aspect of this fatty acid is that the number of carbon atom is always even number. It is always even number. Why it is even number? That is also, if we study the means or the manner in which fatty acids are synthesized in our body, we can understand it well. Otherwise, we cannot understand. Whenever fatty acids are synthesized, always 2 carbon units, acetate units, are always taken and joined one after another. That is why we will always find fatty acids to be even numbered. It doesn't mean that there is no odd numbered fatty acids. Yes, very rarely we find odd numbered fatty acids. Now, next aspect of fatty acids is fatty acids are of two kinds. One is saturated fatty acid, another is unsaturated fatty acids. Another is unsaturated fatty acids. What is the saturated fatty acid? Very simply, if there is no double bond, no CC double bond. If there is no CC double bond or triple bonds are hardly found, triple bonds, then we call it saturated fatty acid. We call it saturated fatty acid. That means every carbon is with maximum possible hydrogens. So that is what saturated. It is, they are saturated with hydrogen. Now when we say unsaturated fatty acid, we mean there are double bonds. The number of double bonds is usually 1, 2, maximum 4 double bonds are there. And whenever there is a double bond, we will find that they are always in cis configuration. They are always cis configuration. Cis means, say when it is like this, CH double bond CH, when these two hydrogens are on the same side, of the bond, we call it cis. So this is cis. If it would be like this, hydrogen, then we call it trans. It is trans. Majority, almost all what we find in our neutral fat, they are cis fatty acids. Rarely there is trans fatty acids. Rarely, very rarely. In some marine organisms, we find trans fatty acids to be present. Now, we will now see some saturated and unsaturated fatty acids. What we find in nature. We will just have a survey. First, we will check what are these saturated fatty acids. As I said, they are very simple to write. We will have the number of carbon atom. How many carbon atoms are there? I have told you that is always even, so there will be 10 or 12 or 14 or 16 or 18 or 20, 22, 24 or 26. Upper limit is probably 26. We have a common name for each. We have a common name for each. We have a common name, we have a systematic name also. So this is capric acid. Then lauric acid, then myristic acid, then palmitic acid, stearic acid, then next is arachidic, next is behenic acid, lignoceric acid, and finally it is serotic acid. So these are the common name, and mostly we use common names while writing these acids, well, these fatty acids. Now, so if we go for their name, systematic name, then you know that we use a term anoic. I mean, a suffix, we will use a suffix anoic acid. To the here will be the number of carbon atom. So this is our method of writing the systematic name. So since here it is 10, so this will be decanoic acid. Decanoic acid. So since here are in the lauric acid there are 12 carbon atoms, so we will write it dodecanoic acid. Similarly, tetradecanoic acid, hexadecanoic acid, then in the steric it is octadecanoic acid, and when it is 20 it is icosanoic acid. And behenic acid, it is do-icosa. Docosa, right, docosanoic acid, and this is tetracosanoic acid. So this is the number of carbon atoms. This is the number of carbon atoms. This is the common name, and this is the decanoic. So this will be their systematic name. Now, another thing also we use while writing them, that is we can present it as a symbol. We can use as a symbol, we can also write. That is what? We simply write how many carbon atoms are there. So say a fatty acid, say when I say 16, means 16 when I say, that means I am speaking about the palmitic acid. So we write it like this, 10, then we put a colon, then we put a 0. What it means? It means there are 10 carbon atoms, and 0 in this part indicates that how many double bonds are there. This is double bonds. So we can write it 12 0, 14 0, and this will be 16 0, this is 18 0, this is 20 0, this is 22 0, and this is lignoceric acid 24 0, and serotic acid 26 0. When we go for the saturated fatty acid, unsaturated fatty acid, we will find these zeros are changing. It will indicate the number of as many double bonds, that number will be present there.